So here's a simple system that we're given, and we're asked to use mesh equations or mesh analysis to find the current in resistor R5. So that would be in this resistor right here. So let's see how we go about doing this and writing our mesh equations. So the first thing we need to do is to define our mesh currents. So we will do that by stating this one first, as this will be I1. So that's the one in red. And then in blue, we'll define this one as I2. So with that defined, we'll look at everything involved with I1 first. And here, remember, we're summing up the voltages in the direction that we're going. So in this case, we will see we have this resistor first, and so that one will just be I1 R1, which R1 in this case, they've defined everything over here on the side, is 1 ohm. Let's write it out first with just the components, just so you can see. It's I1 R1, and then next, you see we have this component here, and so that one we will write then as I1 R2, and then finally we got this component here, so we'll write that as I1 R3. And then we also see that while we do have I1 going through this resistor this way, we should hopefully be able to see we also have I2 going in the opposite way. So that being the case, that's going to be minus I2 R3. So it's going against our other mesh current. Okay? And so that should equal to the voltage V. So in this case, we see that V is working against us. So then that's going to be equal to, and I'll put that, I guess, in red here. And so that means it's going to equal to minus V. So that's everything in mesh 1. So now let's go over and look at mesh 2, which we've designated as blue. So let's go ahead and get the things we have colors associated with already. We see R3, which was purple. So here we're going to say we'll have I2 times R3. But then we also have, like we did before, I1 working against us. So that'll be minus I1 R3. And actually, we can write that in red. That's what we did earlier, right? So you can see the difference there. So it's minus I1 R3. And then like we did before, we're just going to work our way around our loop. So we have that R4 term. So in that case, that's going to be I2 R4. And then finally, we should have this R5 term, which that will be plus I2 R5. And so in this case, V is working in our direction. So what that means, it'll just be equal to V, not minus V in this case. So now if we substitute all the values in where they gave us here and substitute those into these equations, we can rewrite these equations in a more simplified form. So this first equation, that's going to end up being 6I1 minus 3I2, and then that's going to be equal to minus 10. So again, all I did was plug these numbers into the equation and gathered like terms. So it's just basic algebra. And so on the bottom, we'll have minus 3I1 plus 12I2, and that's going to be equal to a positive 10. So here we have two equations and two unknowns. So the one we're interested in, we want to know the current through this device here, this R5. Well, if we can find mesh current I2, that's just the same thing. So if we solve this matrix, again, we can write this in matrix form as 6 minus 3 minus 3, 12. And then this will be I1, I2. This will equal to minus 10 and 10. So again, using any linear algebra approach you like or your scientific calculator, you just divide this into this. And when we do, we come up with I2, which is also equal to IR5, which is what we're looking for. That comes to 0.476 amps, or we would probably rather call that 476 milliamps. So this is the current flowing through R5.